So in assignment number 6, we're going to be solving polynomials by graphing. And the good thing is we're going to be solving these by graphing by using our graphing calculator. And so let's just pull our graphing calculators up, and we're going to reset everything. So if you have something in your graph, we're going to go to second, memory. We're going to go down to reset, and we're going to reset to all the defaults. And reset everything. So you might have something in your y equals, but you can just clear that. And so now when you press graph, nothing's there, nothing's in your y equals, and we're going to start solving some of these equations. We're going to start with ones that look like this. We're going to take a look at number 1. We're going to solve this equation by graphing it. And so I'm going to start by typing that into my calculator. It's going to be x to the third. So x cubed minus 27. And so now I can go ahead and graph this. And when I press graph, you can see that it looks like it crosses at about 3. I may not be able to see everything. I might have to go and change my windows around a little bit, but let's just make sure that 3 is a solution here. So what I'm going to do is go to second and calculate. I'm going to move down to 0 and press enter. And I want to move to the left bound, and so I'm going to move my cursor so it's just to the left of that 0. And so I'm going to move it back here one more. So there's my left bound. I'm moving my cursor here to the right to make sure it's to the right of that 0. And so then I could guess, or I could just enter it, and we can see that one solution really is 3. Well, this is a cubic equation. It's going to have 3 solutions. And so because 3 is a solution, I know that one factor is x minus 3. But what I don't know is, that's a really horrible looking 3. Let me fix that. Let me start over. I know that one factor is going to be x minus 3, so I'm going to have x minus 3 here. But I don't know what my other factor is yet, and so I'm going to have to use long division or synthetic division. So what I'm going to do is have a 1, there's my 1x to the third, no x squareds, no x's, and then a minus 27. And I'm going to divide that by x minus 3. So I'm going to put a positive 3 here. Actually, I should have done this. A positive 3 here, and I'm going to use synthetic division. So 1 plus 0 is just 1, times 3 is 3. 0 plus 3 is 3, times 3 is 9. 0 times 9 is, or plus 9 is 9, and 9 times 3 is 27. Negative 27 plus 27 does give me a remainder of 0, which means x minus 3 really is a factor. My other factor is going to be x squared plus 3x plus 9. And I could try to factor this other expression. I could use any of those 5 methods that we have to solve quadratics. But I think the best method here is going to be to use the quadratic formula. And so I know one solution here is 3. That's when this factor is equal to 0. But if I set this one equal to 0, I'm going to use the quadratic formula. It's going to be negative b, which is negative 3, plus or minus the square root of b squared, which is 9, minus 4 times a, which is 1, times c, which is 9, all over 2 times a, which is 2 times 1, which is 2. And so in my radical sign, I'm going to have 9 minus 36, which is the square root of negative 27. And I can simplify that to, let me go over here, it's going to be negative 3, and then plus or minus. Square root of 27 is going to be 9 times 3, which is 3. I have an I because it's negative, radical 3, all over 2. And so my other 2 solutions are imaginary, and they are negative 3 plus or minus 3i radical 3 over 2. So now let's move on to the second equation. We're going to solve this equation here, but before I can solve that equation, I'm going to rewrite it. I'm going to have x to the third plus 3x squared. I'm going to subtract the x over here so it looks like this, minus x. I'm going to subtract the 3 so that it's equal to 0. So I'll have really this expression, x to the third minus or plus 3x squared minus x minus 3. And when I graph that, you can see it looks like I have all 3 solutions. There are going to be 3 solutions because there are 3 factors if it's cubic. And so it looks like all three solutions are on my graph, which means they're all real. Let's see if we can find the first. I'm going to go for this one first. I'm going to go to second, calculate. I'm going to find the 0, and I'm going to move my cursor to the left of the first 0 here, which is about there. And then I'm going to move it to the right of that 0, which is here. And I could guess, or I could just tell it to tell me what the answer is. And you can see my first solution is x is -3. And I could go through that process of factoring it using long division to come up with my other two solutions, but I think we're going to be lucky here. I think we're going to be able to find our other two solutions on the graph. And so, again, I'm going to go to second, calculate, and I'm going to find another 0. And so this time I'm going to find the second 0 here, so I'm going to move my cursor to the left of it and press enter. I'm going to move my cursor to the right of it and press enter, and enter again. I know one solution is -3, and here's another solution. -1 is another solution. And so if I continue this method here, I'm going to go down, find another 0. I'm going to move my cursor to the left of the final 0, which let's say is here. I'm going to move it to the right of that 0, which is here. And I already know that -3 and -1 are solutions, so another solution is +1. So that this problem right here was a lot easier because all of my solutions were real and they were all nice numbers to work with. Where in this problem, the first solution I could find on my calculator, it was a pretty nice solution at +3, but then the other two solutions I had to find by using synthetic division and then the quadratic formula. So let's take a look at this example here, example number 3. Again, I'm going to move this all over to one side so it's equal to 0. And I have x to the third minus 2x squared. If I add 3, then it's going to be plus 3 equals 0. And so I'm going to go ahead and graph this just like I did the other ones. And if I graph it, it looks like I have one solution. This dip here doesn't get all the way down to the 0. So that means I know they're not going to be real solutions. I'm going to have one real solution, which is this one, and the other two are going to be imaginary. So let's first make sure we know what that first real solution is. Let's find that 0. And again, I'm doing this with my calculator. I'm going to move to the left bound, and then I'm going to move to the right bound and press enter. And it looks like that first solution is when x is -1. And so that means that one factor that I'm going to have is x plus 1, because -1 is a solution. But I don't know what my other factor is going to be yet. So what I'm going to have to do is take x to the third minus 2x squared, and then it's going to be plus a 0x and plus 3. Let me write that down. X to the third minus 2x squared, that's a squared, plus 0x, and then plus the 3, because I moved that over to this side, equals 0. And I'm going to have to divide that by x plus 1. And so I'm going to do it with synthetic division. I'm going to have a 1, a -2, a 0, and a 3. And out here I'm going to put -1. And so I'm going to have 1 times -1 is -1. -2 plus -1 is -3. But times -1 is 3. Plus 0 is, oops, that's 3. And then 3 times -1 is -3. And when I add these together, there's my 0, which is good because that does mean that x plus 1 really is a factor. And my other factor is going to be the x squared from here minus 3x, that's from here, and then plus 3. And so here are my two factors. I know that if this is equal to 0, that if the first factor is equal to 0, I get x plus 1 equals 0, subtract 1, and one solution is -1. Of course, I already knew that from the graph. But then I'm going to have this, x squared minus 3x plus 3 could be 0. And I want to solve that equation. I could try to factor it. I could use square roots. I could graph it. I could complete the square. I'm going to use the quadratic formula here. I'm going to take the opposite of b, which is 3, plus or minus the square root of b squared, which is 9, minus 4 times a, which is 1, times c, which is 3, and that's all over 2 times 1, which is 2. In my square root sign, I'm going to have 9 minus 4 times 1 times 3 is 12. Well, that's -3. And so this is going to be 3 plus or minus the square root of -3, well, that's I radical 3 all over 2. And so these are two solutions. Here's my other solution, and those are my three solutions for that polynomial. Let's move on and see how this applies to real situations. So here we have a dog kennel that's 7 feet longer than it is wide and 1 foot shorter than its width, and its volume is 5.9 cubic feet. How wide is it in inches? Well, we know that the volume is equal to the length times the width times the height. And so we also know that the length is 7 feet longer than the width, so the length is going to be whatever W is plus 7. We have the width, which is just, we're going to call that W. We have the height, which is, it's 1 foot shorter than its width, and so that means it's going to be W minus 1, and the volume is 5.9 cubic feet, and so 5.9 cubic feet. So what I could do is put this in standard form, set it equal to 0, and solve it like we did the first three. However, I think what I'm going to do with this particular problem is I'm just going to type two equations, and one equation is going to be just this side. I'm going to use x for W, and I'm going to have x plus 7 times x minus 1 as one equation. You can see that here. My other equation is going to be y equals 5.9. And so now when I graph these, I'm not going to find a 0. Oops. I'm not going to find a 0. What I am going to find is an intersection point. It looks like there's 3 intersection points, but these 2 intersection points aren't going to make any sense in my situation because we know that W, or my x in my calculator, represents the width, and here the widths would be negative, and that's not going to make sense in the context of the problem. So I want to find this intersection point right here, and so to find that intersection point, I'm going to go second, calculate. I'm going to go down to intersect, which is number 5 for me. Press enter. I want to move my cursor close to that intersection point that I want. Otherwise I could find a different intersection point. And is that my first curve? Yes. Second curve? Yes. I could guess. I could just let it tell me what it is. And it looks like it's 1.47. 1.47, I'm going to round it to 3. And so I think my answer is the width would be 1.473. And so we could then, just to make sure that this is correct, we could go to our regular calculator mode, and I'm going to just type in my width is 1.473. I'm going to multiply that times my new length, which would be 1.473 plus 7, which is going to be 8.473. And I'm going to multiply that times my new height, which is 1.473 minus 1, which is just 0.473. And it should be something close to 5.9. And it is 5.903. And so that is my, my solution, 1.473. However, everything that we've done so far has been in feet. And so they want to know how wide is it in inches. And so it's not going to be 1.473 inches, it's 1.473 feet. And so I'd want to change that into inches. I could multiply it times 12. And when I multiply that times 12, it's going to be 17.676 inches. And so that's my solution to this real world problem. So the last problem we want to do is this. Susan received $1,000 in the bank 4 years ago, and then $800 on her 11th birthday and $300 on her 13th birthday. And so she has a polynomial in the bank that looks like this. And it says that she currently has $2,533.29 in her account, and they want to know what is the interest rate. Well, the interest rate is what X is. And so I'm going to set the amount she has in the bank equal to $2,533.29. There's a 9 there. And then I'm going to put those in my calculator. One equation is the left-hand side of the equation. The other equation is the right-hand side of the equation. And when I go to graph it, it looks like this. I want to find the point of intersection. So I'm going to move down to intersect. And you can see that the intersection point is 1.0599. Well, 1.0599 is really close to 1.06, so it would be about 6% is what she makes on her account. We're going to be doing more problems like this in class, Good luck on your homework, and we will see you tomorrow.